In this class, we're going to get started with the study of classical geometry. This is one of the most important courses in the entire curriculum. It was so important in the ancient world that Plato, who was in charge of a school in Athens, Plato said that no one was allowed in his school unless he studied geometry. No one was allowed in his school unless he studied geometry. That's how important geometry is, and you're going to see why as we get into it. So in this first class, what I'd like to do is provide an introduction to the study of geometry, classical geometry, and then I'd like to walk as far as we can get through the first book of definitions. If the introduction takes too much time, I might just stop at the end of the introduction and use a separate class to go over the definitions, okay? So that's probably what's going to happen. But anyway, let's get started. Get your papers ready, your notes. Put your name and date up at the top of the page. The name of our course is Classical Geometry. Make sure you don't get this confused with Modern Geometry class. This is Classical Geometry. In classical geometry, we're going to study a book written by an ancient philosopher named Euclid. This name, E-U-C-L-I-D, is pronounced Euclid. And the name of the book is The Elements. The Elements of Geometry. So we're studying Euclid's Elements in classical geometry. Now for introduction, let's think about the curriculum that we study, the classical Catholic curriculum. The first subject in the curriculum is the trivium. The second subject we study is the quadrivium. The third subject we study is philosophy. The fourth subject is theology. And the fifth subject is just a collection of a bunch of other subjects, and we call it humanities because they're studies that civilize us. They make us human. So there are 5 subject areas in the classical Catholic curriculum: trivium, quadrivium, philosophy, theology, and the humanities. In the trivium, we study the language arts. We study the beginning of the art of reasoning, rational philosophy, and rhetoric. In the quadrivium, we study the ancient mathematical arts. So the quadrivium is where we learn mathematics. In the quadrivium, we study mathematics. And what is mathematics? Mathematics is the study of what? Who can tell me? Mathematics is the study of quantity. Good. Mathematics is the study of quantity. All right? Now, if you remember in reasoning classes, we learned about genus and species, right? Remember I drew pictures up here about animal and man and all that? Well, this genus up at the top is quantity. The definition of a genus is that to which species is subjected, that which is predicated of many things, to which species is subjected, which answers to the question, what is this? Remember we learned that in reasoning class? Genus is that which is predicated of many things, differing in species, in answer to the question, what is this? Quantity divides into 2 species. Who can guess what the 2 species are? Anybody know? Multitude and magnitude. Good. Okay. Quantity divides into 2 species, multitude and magnitude. A multitude is a collection of disconnected units. A multitude is a collection of disconnected, separate objects that are of the same kind. Like a herd of sheep is a multitude. A pile of coins is a multitude. A nation of people is a multitude. A magnitude is a single thing that can increase or decrease in size. A multitude is a collection of things that can increase or decrease in number. Okay? Multitude divides into two species. Does anybody know the two species of multitude? This is a hard. This is. No, well, that's not right. No. You're thinking You're thinking number and grammar. Well, no. That's another. That's a division of number. That's good. That's good. But I'll tell you, the division of multitude is into absolute multitude. Absolute multitude and not music, relative multitude. Getting ahead of myself here. Absolute multitude and relative multitude. Absolute multitude is simple number. Rouse yourself up. I know it's late. Absolute multitude will be number by itself. Okay? Abstract number. Right? Number by itself. Relative multitude are quantities, multitudes that require us to compare with something else, like 1/2, double. Okay? You have to have two quantities in order to have a relative multitude. You only have to have one quantity to have an absolute multitude. Don't get too crazy with this, because we're not studying multitude in this course. This is arithmetic. Okay? And music. Magnitude also divides into two species. The first species of magnitude is magnitude that is at rest. And the second species of magnitude is magnitude that is in motion. A magnitude is a single thing that can increase or decrease in size. Some magnitudes are at rest. A good example would be the earth. The earth is at rest. Your desk is at rest. Some magnitudes are in motion. The sun is in motion. The moon is in motion. So here's what I want you to follow me with, okay? Mathematics is the study of quantity. Quantity divides into two species, multitude and magnitude. Multitude divides into two species, absolute and relative. Magnitude divides into two species, at rest and in motion. So we end up with 4 different kinds of quantities at the end. You got that? There are 4 different kinds of quantities. That's not a theory, that's a philosophical fact. 4 different kinds of quantities that we have to study, and each of these is studied by a different science. Absolute multitude is studied in arithmetic. Relative multitude is studied in music. Not a modern music class. Don't think about flutes and drums and choir class or anything like that. This is a mathematical art. Music is the study of relative multitude. We're not talking about singing and dancing and playing instruments. So arithmetic is the study of absolute multitude, the study of number. Music is the study of relative multitude or ratio. Magnitudes at rest are studied in geometry. And magnitudes in motion are studied in astronomy. So there are four kinds of quantity: absolute multitude, relative multitude, magnitude at rest, magnitude in motion. And since there are four kinds of quantity, there's a need for four sciences, four mathematical sciences. And the four mathematical sciences are arithmetic, music, geometry, and astronomy. Look right here. What do you see? What does quad mean? Four. The quadrivium, look, 1, 2, 3, 4 sciences. You got that? You got that? Four sciences. Four kinds of quantity, four mathematical sciences, called the quadrivium. The first subject is called the trivium. How many sciences in the trivium? Quadrivium is 4, trivium is 3. You know what they are? You know what the 3 arts of the trivium are? Grammar. What's the second one? Reasoning. What's the third one? Rhetoric. 3 arts, trivium. 4 arts, quadrivium. The mathematical sciences are 4. They're referred to as the quadrivium. That name was invented by a Christian named Boethius, who lived in the 500s. Quadrivium. Okay? So now you should understand, if I say we're going to study classical geometry, follow me here. If I say we're going to study classical geometry, what are we studying? Magnitudes at rest. That's what we're studying. Now, I'm not saying that you know what that means yet, but we're studying magnitudes at rest. That's what we're studying in geometry. So what is this course about? We're studying one kind of quantity, magnitudes at rest. Okay? That's my introduction to geometry. This is what we're studying, magnitudes at rest. Magnitudes are wholes that can change in size or in shape, right? But that's got nothing to do with quantity. A quantity is anything that can increase or diminish. And in geometry, we study magnitudes at rest. Magnitudes that don't move. So there's no motion to worry about. All right? So that's where this study of classical geometry fits into our curriculum. All right? I'll leave that up there for a little bit. Now, what actually is the study of geometry? I said this is called Euclid's Elements. What in the world do we mean by elements? Well, what we're going to do is we're going to study to learn about magnitudes at rest. And in order to learn about them, we don't want theories, we don't want guesses, we don't want some vague ideas. We want real, absolutely certain knowledge of these things. We don't want any cute ideas or opinions or theories. We want real knowledge of magnitudes at rest that's absolutely certain. And the only way that we can build a science, build a system of knowledge that's absolutely certain is to reason from things that are certain to learn new things. We want to reason from things that are absolutely certain, and we want to move to conclusions that we know are absolutely certain. And so the elements, make sure you get this, the elements are the absolutely certain things that we reason from. The elements are the certain, or I should say, they're the truths. Let me call them truths. The elements are the truths from which we reason to build a science of magnitudes at rest. In order to build this knowledge, we already have the most powerful tool that we need given to us at birth, and that's the power of reason. Reason is the instrument that we use to study geometry. But reason needs starting points. Reason needs starting points to draw conclusions from. And what we're doing in the elements in this book, in this study, wise men, and when I say wise men, I mean wisest men who ever lived in history. Wise men worked to learn what these starting points are, what these truths are, and they were all collected in this book, the Book of the Elements. And what we need to do in order to study geometry is we need to learn these truths. We need to learn these truths, and then we're going to use them to reason step by step by step to build a knowledge of magnitudes at rest. These truths, there are 4 kinds of truths. Four truths we're going to learn. The first is definitions. And as I've said before in reasoning class and other philosophy classes, definitions are very difficult to make because you have to really know what a thing is to give its definition. That's why I say these truths were developed and collected by the wisest men in the ancient world. The first thing they did for us is they established the definitions that we need to study geometry. That's number 1. The second kind of truth that we need, they're called axioms. Axioms. Anybody know what an axiom is? We've talked about it a couple times. Does anybody know what an axiom is?
Something that needs to be proved.
Say it again?
Something that needs to be proved.
The opposite.
Something that is proved.
Something that doesn't need to be proved. Okay? An axiom is a proposition that does not need to be proved. It cannot be proved. An axiom is a proposition that's self-evident. Self-evident. That means it's obvious to everyone. A self-evident truth is a truth that's obvious to everyone. Maybe not to a crazy person, but to everyone who is reasonable. And I always give you the axiom as an example. A whole is greater than any of its parts. That's an axiom. It's obviously true. A whole is greater than any of its parts. All right? So the second kind of truth we need are called axioms. The third kind of truth we need are called postulates. Postulates are actions that we may take, operations that we may perform that are self-evident. So axioms are propositions that are self-evident. Postulates are actions or operations. Actions that are self-evident. Nobody will raise their hand and say, wait a minute, how do you know we can do that? They're actions that we can take that are self-evident. An example of a postulate is that if we have 2 points like this, we may draw a straight line between these 2 points. That's an example of a postulate. It's a simple action that we're allowed to perform that no one will object to. Okay? And then the last kind of element, which we'll put a star next to because it's really not an element, and you'll see what I mean when we start studying, is a proposition. Or propositions. And I'm not going to define that right now. We're going to see what propositions are in a few lessons from now. So what I want you to remember, what's most important about this is that these 4 things we're going to learn, these are the elements. These 4 things are the elements this book is named after. When we talk about Euclid's elements, we're talking about the definitions, axioms, postulates, and propositions that are collected and presented to us by Euclid in this book. About 20 minutes? Okay, so we're doing great. All right? So if I were to ask you, do you know what geometry is? Could you tell me what geometry is? Do you have that in your notes? Geometry is the science of magnitude at rest. That's very important in this introduction. What is geometry? The second important thing that you have to make sure you have in your notes is if I said in geometry we study Euclid's elements, what are the elements? Could you tell me what the elements are? Okay. What is geometry? That was the first important point we had to make clear in our introduction. What is geometry? And second, what are Euclid's elements? That's the second important topic. That's the end of my introduction here, okay? So now we're going to look in our book. Look in your book. In your book here, in our copy, this English translation of Euclid's Elements. In this English translation of Euclid's Elements, we see Book 1. Follow me here on your computer if you have the book up. We see Book 1 definitions. And look up here. These are the elements, right? The first set of truths that we need to study geometry, we need definitions. There they are on your page. Okay? What are there, 35 definitions? I forget how many there are. 30, 35? 23. Okay, there's different versions of Euclid's geometry, and sometimes they're divided into more than that. You see how if you scroll down to number 19, 20, 21, and 22, You see how there's actually a bunch of terms in those definitions? You see that? In some copies of Euclid, those are all separated into individual definitions. So in this textbook, we have 23 definitions listed, but really there's more like 35 or 36. Now, what we're going to do with these definitions is we're going to establish the meanings of the words that we're going to use in geometry, just like we do in our other classes. We're going to establish the meanings, and I want you to work to memorize these definitions because you're going to use them in every single lesson in geometry. And I mean that. You're going to use these in every lesson. Okay? So we have definitions to learn, and there's another thing that I want you to realize. Geometry, we're going to talk about figures. Like if you look at the first few definitions, a point is that which has no part. A line is a breadthless length. That means it's a length that has no breadth. And this is going to be a little confusing because if I were to come to the board and if I were to come to the chalkboard and say, this is a point. You all understand that, right? This is a point. But this actually is not a point. Because what does the definition say? A point is that which has no part. What I drew here on the board, can that be divided into parts? Yes, it can. It's actually a visible circle on the board. It has parts. That's not really what Euclid is talking about. When Euclid said a point is that which has no part, a point is something that's invisible. It's invisible. It has no parts. If it's visible, even in the smallest degree, it can be divided. Right? A point is something that we imagine. This is intellectual study. A point is something that we imagine. It has no parts. How can you imagine something that has no parts? It's invisible. And what a point really is just a place. You understand that? It's a place. It's an invisible place in space. And that's a point. A point is that which has no part. So this really is not a point. But, follow me here. When we draw illustrations in geometry, we use this as a symbol of a point. But I want you to understand that this is not a point because this can have parts. A point is something we imagine that's invisible and it has no parts. It must be invisible. It cannot be divided. All right? So that's definition number one. A point is that which has no part. Number two, a line is a breadthless length. So a line, follow me, a line joins 2 points. Right? A line joins 2 points, but it's invisible. Why is it invisible? What does it say? A line is a breadthless length. Can you draw a line that has no breadth? Breadth means width. Can you draw a line with no breadth? No, right? You can only imagine it. A line that's actually invisible. It's a space between 2 points. All right, but when we talk about geometry, we use illustrations and I'll say, these are 2 points and this is a line. But this is just an illustration. This is not really what points are, and this is not really what a line is, because Is this a breadthless length? No. It's as wide as the tip of this chalk, right? So it's a length, but it has some breadth. Okay? And I'm not going to be, I don't want to bother you with this kind of thinking, but I just want you to understand we're going to draw a lot in geometry, but these drawings are just symbols of the ideas. You understand that? What these things actually are ideas in our minds that we can't draw. We can't draw a point. We can't draw a line because it has no breadth. Okay? Now, as we get into the next part of the next definitions, what we're going to do is start with a point, then start with another point, then connect the 2 points, which makes a line. Then we can add another point, and we connect those points, and we connect those points. Now what do we have? A triangle. So you see how we build these figures one step at a time in geometry. That's what we're going to do. We're going to build a knowledge of magnitudes one step at a time, one definition at a time, all through this book. All right? So definition number 1, a point is that which has no part. Definition number 2, a line is breadthless length, or you could say a line is a length which has no breadth. The extremities of a line are points. Extremities means the ends. The ends of a line are points. Definition 4, a straight line, I should be looking at the book here. A straight line is a line which lies evenly with the points on itself. A straight line, so if we have 2 points, a straight line is a line which lies on the path directly between 2 points. In definition 5, we learn a new figure, a surface. A surface is that which has length and breadth only. So a line has length but no breadth. A surface has length and breadth but no depth. So if I had 4 points and I had straight lines connecting each of these points, now what I have here is a figure. Pay attention here. You younger guys can understand this. Geometry is not hard. I now have a figure that has length just like a line, right? You can see that this is a line here. This figure has length, but it also has breadth. It has length and breadth. That figure is a surface. Right here I have a triangle, which we're going to learn about in a minute. I have a line and I have breadth in this figure. I have length and breadth. So this would also be a surface. Okay? You understand that? The same thing would be true of a circle. A circle has length and breadth. We'll get to circles and triangles and all that in a few minutes. A surface is that which has length and breadth only. And the extremities or the ends of a surface, are lines. Do you all see that? The ends of a line are points. The ends of a surface are lines. That's definition number 6. Definition number 7, a plane surface is a surface which lies evenly with the straight lines on itself. That's simple to understand if you just think a plane surface is a flat surface. Flat. All right? A plane surface is a surface where the surface lies evenly with the straight lines, the lines that are its ends. It lies evenly with those lines on itself. Definition 8. A plane angle is the inclination to one another of two lines in a plane which meet one another and do not lie in a straight line. A plane angle. We have two lines with points for ends. And here what we have is another line, right? And this second line could lie right on top of the first line. But if it inclines, we'll have a second line like this. Now read the definition. A plane angle is the inclination to one another of two lines in a plane which meet each other and do not lie in a straight line. Here's where they meet each other, right? Two lines, an inclination of two lines which meet together and do not lie in a straight line, a plane angle. Definition 9. When the lines containing the angle are straight, the angle is called rectilineal. When the lines are straight, it's called a rectilineal angle because the lines could be curved, right? But when the lines are straight, rectilineal means straight line. Straight line. Where are we at time-wise?
37 minutes.
37? Good, we have plenty of time. When the lines of an angle are straight lines, the angle is called rectilineal. Definition 10. When a straight line set up on a straight line makes the adjacent angles equal to one another, each of the equal angles is right, and the straight line standing on the other is called a perpendicular to that on which it stands. I know you have no idea what that means. So let's learn what it means. Because it's very simple. Get rid of all this. All I want to do is read through the definitions as far as we can during our hour tonight so that you can start doing memory work and have an idea of what they mean. Okay? So in definition 10, when a straight line, so here's a straight line, we have these 2 points. We'll say we have point A and point B. And we have a straight line. We have a straight line on these 2 points, or connecting these 2 points. Definition 10 says, when a straight line set up on a straight line, so I'm going to make another line. Here's a point C, and here's a point D. And we're going to have a straight line set on a straight line. Pretty simple, right? Now that you see it, it's easy to understand. When a straight line set up on a straight line makes the adjacent angles. We have this word adjacent. If you don't know Latin, you have to memorize this definition. If you do know Latin, you just have to look at the words and understand what it means. Adjacent means lying beside, right? Not lying like telling a lie. I mean lying like lying down. And the preposition ad means next to. So adjacent means things that are lying next to each other. All right? Our property and our neighbor's property are adjacent to one another. Get that idea in your head? Things that lie next to each other. On my table here, on my desk, I have 2 pens. These pens are adjacent to one another. They're lying next to each other. Adjacent. You're going to see that word a lot in geometry, so learn it. Adjacent. Lying next to each other. Adjacent. When a straight line set up on a straight line makes 2 adjacent angles. Follow me here. I'll explain it, but you have to pay attention. 2 adjacent angles. 2 angles lying next to each other. You see that? 2 angles lying next to each other. This is one angle, and this is one angle. One line is set up on another line so that 2 adjacent angles, these 2 angles, each of the angles is right. What in the world does that mean? It means that these angles are both square. They're straight or right angles. Okay? Like the corner of a square. Both angles are right or straight. If a line is set up on another line and produces 2 angles, 2 adjacent angles that are both right or straight angles, the line that is standing on the other is called a perpendicular. So this line is called a perpendicular line. The word here is perpendicular. And all that perpendicular means is that 2 lines come together and they're straight, right? The angles on both sides of the line are straight angles. This angle is straight and this angle is straight. This line is said to be perpendicular to the other. That's right. Perpendicular lines. Okay? Perpendicular lines. So if I have 2 lines like this, here's one line and here's one line, is this line perpendicular to this? No. Because this angle and this angle are not straight angles. They're not right angles. They're not like square angles. You got that? Okay? So this is perpendicular. This is not perpendicular. Another way to think of this, and this is not the definition, but this is just helpful. A perpendicular line is a line where the adjacent angles are equal to one another, because the only way they can be equal, is if they're straight. Okay? That's definition number 10. Definition 11, an obtuse angle is an angle greater than a right angle. So a right angle is an angle like this. A right angle is like the corner of a square. That's a right angle. If the angle is greater than that, like this, so here would be a right angle, right? But if the angle is greater than a right angle, this is called an obtuse. That's called an obtuse angle. This is called a right angle. So we're just learning vocabulary here. Nothing complicated. The only thing that I think is difficult about the definitions for students is that sometimes you read a definition and you just can't picture what it's talking about. You need some help just to see what it's talking about. So definition 11, an obtuse angle is an angle that is greater than a right angle. And definition 12, an acute angle, it's pronounced acute. An acute angle is an angle that is less than a right angle. Here would be a right angle. We see that this angle is less than a right angle. This is called an acute angle. So we're simply learning the names of different angles. We learned that two lines like this, where the adjacent angles are right angles, this line is said to be perpendicular to this line. Now that I've told you this word perpendicular, you're going to see it all over in your life because it's all over the place. You just don't pay attention to it. Now that you see it, you're going to hear that word every day. Perpendicular. A right angle is like the corner of a square. It's also called a straight angle. If the angle is greater than a right angle, it's called obtuse. If the angle is less than a right angle, it's called acute. In Latin, acutus means sharp. It's like an arrowhead. It's sharp, acute. Okay? Right, the word right, it doesn't mean right hand. It means right as in straight. Okay? An acute angle is an angle less than a right angle. In definition 14, a figure is that which is contained by any boundary. A figure is that which is contained by any boundary. So is this a figure? Is this a figure? Just think of the definition. A figure is that which is contained by any boundary. Is this a figure? Why not? It's not contained, right? Is this a figure? Yes. Is this a figure? Yes. Is this a figure? Yes. All right? That's what that definition means. A figure is anything that is contained by a boundary. A figure is anything that is contained by a boundary. A boundary is that which is the extremity of anything. A figure is that which is contained by a boundary. Our next definition, a circle. If I ask you to define a circle, you think you know what a circle is, right? You can picture a circle. You have the idea of a circle, but if I ask you to define a circle, you won't be able to define a circle. This is the definition of a circle. A circle is a plane figure. What does plane mean? Flat. Good. A circle is a plane figure contained by one line. A circle is contained by one line. There's only one kind of figure, or that's not true. A circle is contained by one line. What would that look like? Is this a circle? It's a figure contained by one line, right? But that's not a circle because definition 15 is not going to be true of this. All right? But this is what it means to be contained by one line. There's one line. Here there's 4 lines. Here there's 3 lines. Can a figure have 2 lines? If they're curved, it can, right? But not straight lines. A circle is a plane figure. So here we have a plane figure contained by one line. That's the second quality of a circle. Contained by one line. such that all straight lines falling upon it from one point among those lying within the figure are equal to one another. What in the world does that mean? A circle is a plane figure. And let me just say this too. When we draw things in geometry, we can never draw perfect figures. So when we draw these things, it's just to help your imagination. Okay? If I draw a straight line, it's really not a straight line. It's not even a line. It's just intended to help you imagine a straight line. Okay? A circle is a plane figure contained by one line. You got that? Such that all the straight lines falling upon the circle from one point are equal to one another. What does that mean? What it means is, if I found one point in the circle, this is what makes it a circle. There's a point inside of a circle. And from that point, if we draw a straight line from the point to the boundary of the circle, and we do that to every point on the boundary of the circle, every one of these lines will be equal because it's a circle. Every point of this line, which we're going to learn, this is called the circumference. Every point of this line, every point of the boundary is an equal distance from the center. That's what makes a circle. That's why this is not a circle. Right? If we found the center point in this figure and we drew a straight line here, that would not be equal to a straight line there. You understand that? In a circle, every point on the circumference is an equal distance from the center. That's what makes it a circle. That's definition 15. Let's keep moving here. We're doing okay. Definition 16, that point is called the center of the circle. That point is called the center of the circle. Definition 17, a diameter. You've heard the word diameter. I'm sure you've heard it. A diameter of a circle is a straight line drawn through the center and terminated in both directions by the circumference of the circle. So what is a diameter? If I were to draw a circle, imagine that that's a circle. We have a center point, and just for the sake of vocabulary, this is not in our definitions, but I just want you to learn this. A line drawn, a straight line drawn from the center to the circumference of the circle, a line like that is called a radius. If the line is straight and extends from one side through the center to the other side, that line going across the center of the circle is called the diameter. Okay, so two important vocabulary words, radius and diameter. Sorry, let me get that on the video. If we have a circle, a line drawn from the center, a straight line drawn from the center to the circumference is called a radius. A line drawn from the circumference, a straight line drawn from the circumference through the center to the other side of the circle, that straight line is called a diameter. So a line from the center to the circumference is a radius. A line from one side of the circle through the center to the other side is called a diameter. This word diameter, dia, means a through or across, and meter means measure. So diameter means measure across. The measure across a circle is the diameter. Okay? That's definition 17. We're about,
55.
yeah, we're going to stop right there. Okay, so we're going to stop at definition 17. We had a full introduction to geometry and we started walking through the definitions. In our next class, what we're going to do is we're just going to start from the beginning of the definitions. Okay? So we had a good introduction to the definitions. In our next class, we'll start over at the beginning of the definitions and we'll make one video, we'll make one class that covers all of the definitions. Okay? So that's all for our first lesson in classical geometry. I know that's a lot of information, right? You got your money's worth from that class. What I want to make sure you understand in this first class, remember I gave you two questions. What is geometry? And what are the elements? What is geometry? What are the elements? We learned that there are 4 kinds of elements: definitions, axioms, postulates, and propositions. And you see what we do in this first lesson is we just start learning the definitions. Okay? These definitions are to be memorized. They're very important. If you get any part of the definition wrong, you'll be confused in the lessons. You have to make sure you memorize these because every detail is important. Okay? So take a minute, write a quick summary of this lesson. In our next class, we're going to go over all of the definitions carefully and in detail. And I'd like you to start working on memorizing them so that we can have the definitions memorized within a week or so, because we're going to have to also study the axioms and postulates. And then once we get started with propositions, we just go one proposition per lesson until the end. And that's it. All right? So write up your summary, and that's all for our first class in classical geometry.